Hello student, welcome. In this video, our new topic, we are going to start our new topic of grade 9 sequence and series. So it is totally a new chapter for you, new topic or chapter for you. The first is introduction to sequence. Let's know what sequence means. You will see a figure, first figure, and the figure is created by using boxes, square boxes. There are 3 square boxes in the first figure, and second figure you can see the boxes, one more boxes on the top, so total, and one more boxes on the bottom, so it's total, it is 5 figure in 5 boxes, square boxes. And in this way, like in third figure also, one more boxes is added in the base and one boxes is added at the top, and one more boxes is in fourth figure, one more boxes is added on the base, and in middle also one more boxes is added. So the number of terms, number of boxes, you can easily count the number of boxes. Now let's see few question. You will see few question and you have to answer those questions. Now see the first question: how many boxes are there in the first figure? We can easily count, and there are 3 boxes, isn't it? So there are 3 boxes. And next question: how many boxes are in the second figure? And there are 5 boxes. We can count the square boxes. How many boxes? We're trying to learn. We're trying to learn what sequence is actually. So how many boxes are there in the third figure, in third and fourth figure? The answer is, you can easily answer it, 7 and 9. I think 1 2 3 4 5 6 7 8 9, 7 in third and 9 in fourth figure. So 7 and 9. Now all these numbers can be grouped together and write on a single line. So the question is, write all these numbers related to each figure on one line and separate them by comma. The answer is 3, 5, 7 and 9. Now 3, 5, 7 and 9 is a sequence of a number. Sequence is a number formed by counting the boxes on the figure. It is a sequence of a number formed by counting boxes on the figure. Figure are on the form of pattern, isn't it? It's like a pattern. Pattern is created by applying the boxes, square boxes, and the number of boxes, if we count the number of boxes and group them together, this group of numbers, and separate them by the comma, they are sequence. Now they are called sequence. Now guess how many boxes will be there in the fifth figure. Guess it. Keep your answer to you. We will come to this later. Now let's see the definition of sequence. This is a sequence. Actually 3, 5, 7, 9 is a sequence of number formed by counting the number of boxes on each figure. Now definition of sequence: if the group of numbers are arranged on a fixed rule. Now there is a word fixed rule. There are 2 words, fixed rule, and we will come to this later. What does fixed rule means? Separated by comma, then such arrangement is a sequence. Now sequence is nothing but just an arrangement of numbers and on a fixed rule. Number must be arranged on a fixed rule. The fixed rule, the word fixed rule, has a significance on the definition, and we will understand it later on. It is a group of number arranged on a fixed rule and separated by comma, and such arrangement is called sequence. Now see the sequence, our sequence. It's 3, 5, 7, 9, and first term, the 3 is the first term, and second term, and third term, and fourth term. And those dots means it has a meaning. Goes on forever. Now goes on forever to infinite. Okay, to infinite, and these are terms, element or member. You can use the word terms, or you can say it's an element of a sequence, or you can say that they are the member of a sequence. It's same thing. Now see the arrangement of utensils on your kitchen. How the utensils are arranged on your kitchen? They are arranged on a proper sequence. Let's move forward and understand what fixed rule means. Now let's understand what will be the next number on the above sequence. The answer is 11. And how answer is 11? Okay, our sequence was, we can rewrite the sequence. Our sequence was 3, and there was 5 on the second, 7 and 9 on the last. Now how can we know our next term? Our next term is 11. We You can say it's 11. You have guessed it correctly. And how were we able to say it is 11? We were able to say 11 by a fixed rule, because the number that are associated with each other by a rule, that is 2. See, to the gap is 2. This is a fixed rule. This is called fixed rule. Now every number on this sequence, the gap between the every number in this sequence will be 2. So next will be 13, isn't it? The gap must be 2. Next will be 15. We can easily write many more. 15, 17, isn't it? The gap we must keep the gap 2, so that this is the fixed rule. Now this is a sequence. Now we can call this a sequence. And another example, let me tell you. 1, 4, 9, 16. Now see the gap. Gap is 3, gap is 5, gap is 7, isn't it? Now you can say they are not equal. The difference between the two numbers are not equal, but still this is a sequence, because see the gap. The rule on the gap is fixed, isn't it? The rule on the gap is 2. Rule on the gap is 2. So we can easily guess the next number to be 25, isn't it? To be 25. It will be 9 here, and the gap on the rule will be 2. So it is a sequence, or in another word we can say the sequence, because this is the square of 1, this is the square of 2, this is the square of 3. There is a fixed rule. The sequence is formed by applying a fixed rule. There is a fixed rule, isn't it? It has a 4 square. There is a fixed rule. Every number is a square. It's a square number. So there is a fixed rule. So this is the fixed rule. Randomly arranged number are not called sequence. Now if I give an example, 1, 0, 4, 3, 2 and 8. Now this is also a group of number, but it is not called a sequence, because it does not have any rule. It is just a randomly placed number, and it is not a sequence. Understand? To be a sequence, there must be arrangement of number, but the number must be arranged in such a way they must be connected by a rule. The terms or members or element must be connected by a rule. There must be a fixed rule between the elements or number. You can say elements, number, or member. Now, so I hope you understand. Now, how were we able to calculate? Able to answer 11? Now we were able to answer 11. It's an explanation of what we just now illustrated. We were able to answer this question because of that fixed rule. That rule difference between the two number is always 2. Now see, the difference between two number is also, that's why we were able to say the next number will be 11, because the difference between the number was kept as 2. So we understand sequence. Now let us study this sequence. A, B, C, D. There are 4 sequence, and you can see in first sequence we can count the number of terms. There are 4 terms we can see, but dot means there are many more terms on the sequence, and these are sequence. We can easily guess the next number, because 5 square, 5 cube, 5 to the power 4, and 5 to the power 5. The next, it is a sequence, proper sequence, 5 to the power 4. We can guess another number also. It will be 64 and 120. I think it's 128. 2, 4, 8, 16, 64, 128. It must be 128. And next number will be 256. 256. Isn't it? Next number 1, 3, 6. Now 3 the multiple of 3. Multiple of 1, 3, 16, 15. Now you can easily guess it will be 21. The gap is increasing. It's 2, it's 3, it's 4, it's 5, it will be 6, isn't it? Now in these A and C we can't count the number of terms, because how many terms are there we don't know about, but B and D, we can exactly count the number of terms: 1, 2, 3, 4, 5, 6, 7 terms in D, and in B and D, 1, 2, 3, 4, 5, 6, 7 terms in D also. In A and C, there are many terms. There are uncountable terms. In B and D, there are countable terms. So we can count the terms easily. And what does it means? Our observation: sequence B and D have fixed number of terms. Yes, correct. And sequence A and C does not have fixed number of terms. So sequence having fixed number of terms or elements or member is called finite sequence. Now try this. Add two more terms to the given sequence. We have to add two more terms. We can easily add two more terms. See, it will be 11, I think, and 11 and 13. You can easily add, and you can easily do these questions. And another, identify the finite. A general term. What is general term? Let's revisit our the previous sequence. This is a sequence, and what will be the next term of the sequence? We can easily write it is 11, isn't it? It is 11. What will be the next term after 11? We can write easily 13. Now next term is 11, next term is 13, isn't it? Now these are the number of boxes on each figure. Yes, these are the number of boxes on each figure. We have seen the figure in very first slide. And so these are the number of boxes in each figure. Can you tell how many boxes will be there on 17th figure? You can tell how many boxes will be there on 17th figure manually, isn't it? And it will take time, little bit time. We have already found 1, 2, 3, 4, 5, 6, and for 17 we can go on like this. After 13 it will be 15, 16, 15, and then 17, then 19. In we can find the number of boxes on 17th figure, but it will take time. And can you tell how many boxes will be there on 15th figure? It will take more time, isn't it? It will take more time, maybe some half an hour or more than to calculate the number of boxes on 17th figure. And can you tell how many boxes will be there on the nth figure? Nth figure means n, value of n may be any. It may be 100, 200, 300. So it is a time consuming task to do it manually, to do it by one, okay, manually one by one. For this we need a formula, a specific formula which can easily calculate the number of boxes or number of dots, number of value on any term, isn't it? In any term. So that formula is called general term. To make our work easier, the general term, we have to find the general term. General term help us to find any number of boxes on any figure. So the formula to make our work easier, that is general term. The formula to find the value of nth term in any sequence, to find the value of nth term, there is a formula is created, and that formula is called general term. Now how to find general term? First we have to understand linear and quadratic sequence. First let us consider a sequence. See, and in this sequence the difference between the two terms is 2, 2, 2. So A equal first difference. Okay, in the first sequence, the first difference, it is called first difference. This whole line is a first difference, and first difference is equal. So let's see in the second sequence, the first difference is not equal, unequal first difference, but the second difference is equal, and it's represented at 2a, and it's represented as a and 2a is used to represent first difference and second difference. In this first difference, and let's see, in this first difference, in this sequence, first difference is equal. This type of sequence is linear sequence. So this type of sequence is called linear sequence. So if the first difference is equal, then it is called linear difference, a linear sequence. And another example for the linear sequence can be 2, 4, 6, isn't it? Even numbers, 8. This is also linear sequence. Another multiple of 2, or you can say odd numbers. And this is even numbers. These are even numbers. These are odd numbers. And 3579 are odd numbers. 3579 are odd numbers and 246 are even number. This is another example for linear sequence. And you can give another example for the linear sequence will be 4, 9, 13, 18, 13, 18. It is an example of linear sequence. See, the gap is 5. Gap is 5 means it must be 14 here and it must be 19 here. So gap is 5, gap is 5, and gap is 5. So it is another example for linear sequence. Now when the second difference is equal, then it is called quadratic sequence. So if in this sequence second difference is equal, so this type of sequence is called quadratic sequence. Now when first difference is not equal and second difference is equal, then just those type of sequence are called quadratic sequence. So I think it's clear to you. A linear sequence. A linear sequence with equal first differences. The sequence with equal first difference is called a linear sequence. The general term for the linear sequence is given by Tn equal to a n plus b. You have to remember this part. The general term of the linear sequence is always a n plus b. Now, where n denotes required number of terms. Let us consider a sequence. Now, how to construct a sequence? Let's see. When value of n is 1, you can easily say it will be a plus b plus b. When value of n is 2, you can easily say it will be 2a plus b. 2a plus b. And when value of n is 3, you can easily see 3a plus b. Isn't it? We have to put the value of n right here, 1a, 2a, 3a, and it goes on to 4a plus b. So these are the linear sequence, isn't it? They are constructed from the formula of general term of linear sequence. So let's see the sequence. You can see the sequence, and the gap between these two is, you can easily calculate the gap between these two is a. How to calculate? Let's see. 2a plus b minus a plus b on bracket. If we open a plus b, then it will be 2a plus b minus a minus b. So b and b got cancelled and 2a is subtracted with a and we can find a. Similarly, that is a, that is also a, you can do it. Now first difference is equal. As it is a linear sequence, the degree of general term is 1. So degree of general term will be 1. You can see the value, the power, the index of n is 1. And now keep in mind, a is equal to value of first difference. You can see a is equal to value of first difference. It's the value of first difference. And a plus b is the first term of the sequence, which is a plus b is the first term of the sequence. On putting the value of a and b on Tn, we can find general term of linear sequence. Now this box will be seen every time we do these questions. Now let's quickly move to from linear to quadratic. Now, example to understand. It's another example to understand. Find the general term of the sequence. Now there is a sequence. Its solution. The given sequence is 5, 2, minus 1, minus 4, and minus 7. Now the gap is, what will be the gap between these two terms? Can you tell me? the gap will be minus 3 because the second term is smaller than the first term, isn't it? 2 minus 5, 2 minus 5. We have to do not 5 minus 2, must be 2 minus 5. That will be minus 3. Now, same goes here. It will be minus 3, it will be minus 3 and minus 3. Now our first difference is equal, isn't it? First difference is equal. So we have a process to solve to find the general term. Now first difference is equal, then it is linear sequence. So it is linear sequence and its Tn will be an plus b. Now see, it is a linear sequence and Tn an plus b, and its equation 1. We need it later on. Now we have the value of a also. You can see in the third step, a is equal to value of first difference. So first difference is 3. A, it is a. Right here is a. So we have a first difference a equal to minus 3. Also in next step, a plus b is equal to first term of the sequence. Now 5 is the first term of the sequence. The first term of our sequence is 5. So or minus 3, we can put the value of a as minus 3 plus b is equal to 5. Now b will be 5 plus 3. You can see 5 plus 3 and it will be 8. Therefore b is equal to 8. We have the value of a right here and we have the value of b also. We can substitute this value of a and b on equation 1 and we can easily, putting the value of a and b in equation 1, we get minus 3. Putting the value of a as minus 3 and putting the value, this is a and this is b. So therefore Tn is equal to 3 minus 3n plus 8, or you can write 8 minus 3n also. You can write 8 minus 3n. Now this is the way, these are the steps to calculate the general term of any linear sequence. Let's quickly move to another. Topic now, quadratic sequence. The sequence with equal second difference is called quadratic sequence. Now first, if there is equal first difference, then it is linear sequence, and equal second difference, it is quadratic sequence. The general term is given by, you have to remember this general term, Tn is equal to, for quadratic sequence, it is a quadratic sequence, so the degree of n, you can see the polynomial, or you can say the expression is 2, so it is a quadratic sequence. And now let's create a few terms here. What will be our T1? We have to substitute the value of n to be 1. That will be a plus b plus c. Our first term will be a plus b plus c. Similarly, second term will be, second term t2 is equal to, now the value of n will be 2. 2 square is 4. That will be 4a plus 2b, 4a plus 2b plus c, isn't it? Now let's get one more term. Let's find one more term. In this way you can find many terms here. It will be 9a, isn't it? 3 square is 9a. 9a plus 3b plus c plus c. Now what will be the difference between t2 and t1? Difference between t2 minus t1. Let's find it first. T1, our t2 is 4a plus 2b plus c, our minus, let me change the sign, a minus b minus c. It will be, sign will be changed, so it will be a minus b minus c. C got cancelled, isn't it? And b and a will be subtracted, so it will be 3a plus b. 3a plus b, a and b got subtracted. So let's see where and let us consider a linear sequence as, now it is a first term, we have just found it, second term and third term. First, second and third term. So similarly we can find fourth term also. Now a plus b, now let's see the difference between these terms, 3a plus b we have calculated here, right here. Now similarly these two also we can calculate. The difference will be 5a plus b, you can do it yourself, and their difference will be 7a plus b. Now let's see, this first difference is unequal, isn't it? They are not equal, it is the first difference. But let's see the second difference, 5a plus b minus 3a plus b, the value will be 2a. Easily you can find, if b and b got cancelled, 5a minus 3a, 2a. Now similarly 2a. Now we have an equal second difference, so when there is an equal second difference, it is a quadratic sequence, we have already discussed about it. So that is, we have to keep in mind, 2a is equal to value of second difference, 3a plus b the first term of the first difference. Now this is the first difference, entire line is a first difference, and this is 3a plus b is equal to first term of first difference. Now and this is the first term of our entire series, this is the first term of entire series. A plus b plus c is the first term of given series. On putting the value of, after finding the value of a and b and c, we can put the value of a, b, c on Tn, then we can easily find the general term for quadratic sequence. Let's move forward. As it is a quadratic sequence, we have already said and discussed about it, is the degree of general term will be 2, so it will be square, it will be on a square form because it is a quadratic sequence. Quadratic means having the power 2. Now let's see example to understand, like in linear also. Now let's see the difference, the first difference. Let's see the first difference. I think first difference is not equal, 2, 3, 4 and 5, it is not equal, and the unequal first difference, we can easily say the next term will be 21. Okay, you can easily say, if you have guessed it 21, then it is correct. First difference is unequal. Let's see the second difference. It's equal because it is a quadratic sequence. Second difference is equal. What happens when second difference is equal? Let's see here in our figure. Keep in mind, if the second difference is equal here, second difference is equal, then it is a quadratic. So we have to write, since second difference is equal, it is a quadratic sequence. Now for quadratic sequence, our Tn will be an square plus b, it is equation 1. Now we can get the value of a right here. 2a is equal to value of second difference. Value of second difference is 1, so 2a equal to 1. Our a will be 1 by 2. Let's see, we have 2a is equal to 1, so a will be 1 by 2, isn't it? 2a is the value of second difference, second difference is 1, so 2a is equal to 1, a is equal to 1 by 2. Now 3a plus b is equal to first term of the first difference. This entire is a first term, so first term of first difference is 2, so 3a plus b will be equal to 2. 3a plus b is equal to 2, isn't it? I think you understood it. 3a plus b equal to first term of first difference. This is the first difference, this entire row is the first difference, so its first term is 2, so 3a plus b is equal to 3a plus b will be equal to 2. Now we can put the value of a right here. See, we can use the value of a and we can find the value of b. Now 3a plus b, you have a calculator, you can easily calculate. B is equal to 2 minus 3 by 2, which is a. Also we have completed up to this step. Fourth step, fifth step, a plus b plus c is the first term of given sequence. Now this is the first term of given sequence, that means a plus b plus c is equal to a plus b plus c equal to 1. A plus b plus c is equal to 1. Now a plus b plus c is equal to 1, value of a is 1 by 2, value of b is 1 by 2, plus c is equal to 1. So or 1 plus 1 half plus half is what? Half plus half is 1, so c, we can cancel this one. C is equal to 1. Now we can put the value of a, b and c in equation 1. Now we can see 1 by 2 n square plus 1 by 2 n plus c is equal to 0, which is equal to, now we can write as n square by 2 plus n by 2 n by 2, which is equal to, LCM will be 2, isn't it? That will be n square plus 2 plus n only. Now we can take one, see, same thing will be shown. N square plus 2. Denominator is same, means LCM will be the same number, that is 2, and if LCM is same, then we can just add the numerator, and here the terms are common, so you can take common n plus 1 by 2. Now our general term Tn is n plus 1 by 2. So this is the process. You have to follow this entire process. Then you can easily find the general term of any quadratic sequence. This, keep in mind, is very important. It gives you the perfect idea on how to calculate the general term. Some important workout examples. You can see. First example is on your screen. Here the general term is Tn square. General term Tn is equal to 3n square. General term means we have to represent by square minus 5. Now, so we have to find the first 5 terms, means our input must be n equal to 1, 2, 3, 4 and 5. Now let's see, here Tn is equal to 3n square. Let T1, T2, T3, T5 be the first 5 terms of the sequence. Now we have to find first 5 terms, so we suppose these to be T1, T2, T3, T4 and T5. Now T1, to find T1, the value of n will be 1. We have to substitute the value of 1 to be n to be 1. So this is n, isn't it? N square minus 5, the value will be 3 into 1 minus 5, which is equal to 3 minus 5, which is equal to minus 2. Similarly for T2, T2 is equal to, now n will be replaced by 2, isn't it? It's like a function, and input variable takes the input value, isn't it? Input value replaces input variable. So our input value is 2 and it replaces the n, that is our input variable. Now we can proceed. Now for 3, n will be replaced by 3. And on calculation we can easily see, and 4 also we can do it easily. So is the easy. Now second question, example 2, nth term is given. We don't have to find all term, we just have to find T5 and T6. T5 and T6. So n will be 5, n will be 6. Okay, we have to first substitute here. Tn is given to find T5. When n is equal to 5, we have to input 5. Now T5 is equal to, all n will be replaced by 5. You can see on your screen, all n, wherever there is n, see, n will is replaced by 5. Now there is n right here after 75, that is also replaced by, and that is also replaced by 5. Now on calculation, you have a calculator. Now this 5 minus 1 is 4, and into 75 into 5, 375. Now entire calculation of this denominator is 15. So now we can cancel. We have some note for you. Keep in mind, minus 1, if the power is even, then the value will be 1. See, after this step, you can see when value is odd. Right here we have value even power, minus 1 to the power 4. It is even power, so the value will be 1. You can see it's 1 into 375 by 15 upon 15 cancelled by 25. Now the answer is 25. Now to find T6, you can easily do, you can pause the video, you can do it and check the answer later on. Now to find T6 when n is equal to 6, now n will be replaced by 6, entire n will be replaced by 6. You can see right here the 6 minus 1 into 75 into 6, isn't it? N is replaced by 6. Now 6 is square minus 6 minus 5. Now you can see the next step, 6 minus 1 will be 5. Now 75 into 6 will be 45, 450 and 25. The entire calculation will be 25. Now it's odd power, so it will be negative value. Minus 1 to the power odd, that is minus 1. Minus 1, now if we cancel, it will be 18 times. it will be 18 times. The answer will be minus 18. So our answers are T5 is equal to 25 and T6 is equal to minus 18. So this is very important question. Let's move. Example 3. Example 3. Now see, general term is given. Our general term is given in this form, un plus 1, and we have to find t2 and u2 and u3. Our u1 is given. So let's write the general term first. Un equal to, let me bring the pen. We need pen. Now see how to start the supposition and how to put the value of n. Let me tell you, if tn is given, then we have to start with the given number. Like if we have to find u2, then we have to start with 2. Is it t2? Then we have to start with 2. T2. Let's write t2. Now if it's given tn, and if the general term is defined as tn, then we have to start with the given value. If we have to find t2, then we have to start with n equal to 2. T3, then we have to start with n equal to 3. But if it is given in like this, t n plus 1, then we have to start with one less number. So if it is, then we have to find t2, then we have to start with n is equal to 1. N is equal to 1. With n is equal to 1, if we start with n is equal to 1, then we get t2. Okay, now if it's tn is given like tn minus 1, then we have to start with one more number. We have to find t2, then we have to start with n is equal to 3. Now but our tn is given in this form, then we have to start with one less number. That means if we have to find t2, we have to start with n equal to 1. N is equal to 1. When n is equal to 1, we can see u1 plus 1, n replaces 1 replaces n. Instead of 1, instead of n, it is instead of you can see instead of n, it is written 1 1 right here also. Now you can see u2 equal to 1 minus u3. The value of u1 is right here. u1 is equal to 3. And now on calculation, you can use your calculator, and we found 2 by 3 u2. So we found the value of u2. Similarly, u2 is equal to 2 by 3. Similarly, we have to find u3. When n is equal to 2, now to find 3, we have to suppose one less number. And now n will 2 will replace all the n's. So you can see in general term n plus 1, so it is 2 plus 1 and t2. We have the value of u2 right here. 2 by 3 is the value of u2. We have to replace u2 by u3, and now this 3 will go and multiply with 1. This 3 and go with multiply with 1. Now u3 is equal to 1 minus 3 by 2. On calculation, you can see minus 1 by 2. Let's move to another question. Example 4. This is our given sequence, and now let's see the solution. The given sequence it's in the fraction form. We haven't done this type of question right now. It's in the fraction form. Now before we move further, let me tell you one thing. Let's make a sequence from the numerator. It will be 1 4 1 4, and now let's keep the gap and 10. And now student, tell me what will be on the gap. And for this is for numerator. This is the sequence of numerator. And let's construct a sequence for denominator also. D is equal to 3 5 and gap and 9. Now what will be on this gap and what will be on this gap? If we think carefully, if you observe carefully, then you can easily say the number will be 7 here and number will be 7 here also. Instead of 1, we can write 7 upon 7. Now see the sequence. Gap is 3 3 3, so there will be 7, and gap is 2 2 2. Now gap is 2, isn't it? Now the number will come with the gap 2. This number must come with the gap 2, isn't it? Now the 7 comes with the gap 3. Right here also 7 comes with the gap 3. So we can use, instead of 1, 7 by 7. Now let's see. 1 by 3, 4 by 3, and there is a gap 10 by 9. And now in the gap we can write 7 by 7. And now let's proceed forward. What we are going to do, you can see the idea is finding Tn for numerator. We have to find the we have to find the Tn for numerator, then we will find the Tn for denominator also. This is the sequence for numerator, and there is a sequence for numerator also, and there is a sequence for denominator also. Now if we can use this both numerator and denominator, both two sequence, and we can find the general term, and if we combine and later on, then we can easily find our general term for the entire sequence, which is given in fraction. For numerator, the sequence for numerator is 1, 4, 7, 10, and let's see, is it a linear or a quadratic? 3, the gap is 3, gap is 3, gap is 3. So gap are equal. First difference are equal. It's the first difference. Now if the first difference is equal, then we can see, we can easily see the first difference is equal, then it is a equal, then it is a linear. It's a linear sequence. So for linear sequence, our Tn is equal to so Tn is equal to an plus b. It's equation 1. Now we have a right here. It's a, isn't it? You can see this third step, value of first difference. The value of first difference is a. So we have a here. A is equal to 3. And again in fourth step, you can see in fourth step, a plus b is equal to first term of the sequence. Our first term of sequence is 1, so a plus b is equal to 1. Now we have the value of a. We can substitute the value of a and find the value of b. 3 plus b is equal to 1, or b is equal to 1 minus 3. The value of b is minus 2. Now we can put the value of this, putting the value of a and b on equation 1. We get Tn equal to 3 minus 2. Now we find the general term for numerator. In the same way we will find for a denominator also. Now the solution is still not completed. We have just found the general term for numerator. Now we have to find general term for denominator also. Let's see the sequence for denominator. The sequence is 3, 5, 7, and 9. You can see this sequence. It's the original sequence. It's the sequence given in the question, and we replaced 1 by 7 by 7. So let's see, is it a quadratic, or this is quadratic or linear sequence? 2, 2, and 2. First difference is equal. So first difference is equal. Then you can see the process on your screen, on the right side of your screen. First difference is equal. It is a linear sequence. Since first difference is equal, it is a linear sequence, and so Tn will be an plus b. Now we know what a is. Our a is 2, because first difference equal first difference is our a. So a plus b is equal to first term of the sequence, a equal to 2, and now a plus b is equal to first term of the sequence. You can see here a plus b is equal to first term of the sequence. First term of the sequence is 3. 3 is a plus b. A plus b equal to 3. And now we have the value of a, so we can substitute the value of a as 2 plus b, or 2 plus b is equal to 1. Now b is equal to 2 minus 1, 1 minus 2. Now b is equal to, or b is equal to minus 1. Now putting the value, putting the value of a and b on equation 1, putting the value of a and b on equation 1, we get Tn is equal to 2n minus 1. This is a and 1 is b. Now we have we have we have we have Tn for numerator, Tn for denominator. Let's combine it now. Now recap. We have found on one slide, in another slide. Now we have done this first part, finding Tn, and second part also finding Tn for denominator also. Now it's remain to combine both. So let's see now the general term for entire sequence equal to Tn numerator upon Tn denominator. So that will be 3n minus 2. Tn numerator is 3n minus 2 and 2n minus 1 is Tn for denominator. Now what Tom has to say, let's see what he has understood. Tom has understood that if the sequence is in fraction, then we have to find the general term of both numerator and denominator. So Tom has understood correctly. So does you. Try these questions. These are the exercise question for you. All these questions are you can do it. All these questions by if you have understood those examples, then you can easily do these questions. Okay, student. Finally, we are on to series. We have already studied about the sequence, and now it's time to know about the series. So, introduction to series. Let us consider a general sequence. General sequence means a sequence written as T1, T2, T3, T4, and T5. As you know, there is the number of term on the series. Number of term on the sequence is not fixed. It is not definite. It's dot dot dot. It's to infinity. So it is an infinite series, infinite sequence. Sorry. Now this is the equation 1. Let us add first 4 terms of this sequence. This T1, T2, T3, and T4. Let's see. T1 plus T2 plus T3 plus T4. It's equation 2. Here, terms of the sequence are expressed as a sum. They are added, isn't it? All the terms are added, or they are expressed as a sum. Now, this type of representation of a sequence, this type of representation of sequence is called. This way of representing sequence is called series. So series is nothing; it's a sequence, but the terms of the sequence are combined, or they are connected, or they are, you can say, separated by the operator. Here it's a plus operator. We can use minus operator also. A plus and minus, multiply and divide are operator, but we only use plus and minus to express sequence as a series. So series is nothing, it's just a sequence. It's a sequence, but the terms here in the sequence are combined, you can say, are separated, or you can say connected, are associated by operator. Now let's say the definition. If the terms of any sequence is combined by operator plus and minus, then it is called series. So that's the series. Now let Tn be the general term of the series 2. Then it is written as Tn is written as general term 2. General term of the 2 means equation 2. It's equation 2. If it's general term, Tn, if it's represented by Tn, and then it is the general term of the sequence of 4 terms is represented by Tn, then its series is represented as summation. It is called summation, and you have seen this here, and actually in statistics you have seen in class 8 fx upon n, isn't it? That's a summation. We add the product of fx, we add all the product of fx. It means we all add all the product of fx, so it means we add all the values t1, t2, t3 and t4, and these 1 and 4 are parameters, means n starts from 1 and ends at 4. It means n starts from 1 and ends at 4. Summation is called sigma or summation, and it adds all the terms under its parameter. Here parameter is n is equal to 1, 2, 3, 4. Parameter means boundary. It's boundary or area of influence. You can say area of consideration, terms of consideration. So I think it's clear. Series is nothing but a sequence where the terms are separated, or you can say combined by operator. Only plus and minus operator are considered, not multiply and divide are not considered. Now let's move to another one. Now this is a term, actually it's sequence. Hello, I am sequence. So we will see another one. Hello, I am series. Now what we are going to do is we are going to see the difference between sequence and series. I think it's clear to you what is the difference between sequence and series. Now let's see what sequence has to say. If the group of numbers are arranged on a fixed rule, we know what fixed rule means, and separated by comma, arranged on a fixed rule and separated by comma, then such arrangement is called sequence. In the same way, if the terms of any sequence is combined by operator plus or minus, then it is called series. The terms of the sequence, if they are combined together by the operator, then it is called sequence. Now second, it's the example of sequence. You can see example 2, 4, 6. It is a sequence because the terms are associated. They are arranged as a fixed rule because the gap is 2, isn't it? So easily we can find the next term 12, it will be 14 and it will be 16 and so on. Now there is a fixed rule and they are arranged and they are separated by comma. Also you can see example 2 plus 4 plus 6. Now here the terms are not separated by comma, they are combined by operator. So this is the difference between sequence and series. While you are doing on your copy, where you're making the note, you just make table sequence and say 2 columns sequence and series. Make a table structure and write and note it down. Example, one example. It's 5th example. Expand and find the value. Here n runs from 3 to 6, means it takes the value 3, 4, 5 and 6. It takes the value 3, 4, 5 and 6. So n takes the value 3, first 3, then it takes the value 4, 5 and 6. A solution. Here summation n runs from, it's n runs from, okay, the variable runs from, it's, if it is not written n also, it means n runs from 3 to 6. Now which is equal to 3. Now first n takes the value 3 and now again it takes the value 4 and n takes the value 5. You can see n takes the value 6 right here, n takes the values only 6 because it runs from 3 to 6, and they must be separated by plus sign because it's a summation. Summation means addition of the values. This actually is a third term, isn't it? T3. This actually is a T4. This actually is a T5, and this is a T6, isn't it? Now all these are added. We have to add the value of T3, T4, T5 and T6. You can separately find T4, T5, T3, T4, T5 and T6 and add, or you can do like this. If you understand, then you can do it like this because it will save your time in examination also. But if you are not sure, if you find difficult on doing directly like this, then you can find T3, isn't it? T3, and the term will be this term, and T4 this term, T5 T6. Now value, you can use your calculator. 3.9 because 3 square is 9 right here, and 4 square is 16 right here, and 5 square is 25, as you can see, and 6 square is 36. And we can add it. We can add it to 27 plus 1. We can first multiply and add, then 48 plus 1, then 75 plus 1, 75 plus 1, then 108 plus 1. Okay, now the addition will be 28 and 49 and 76 and 109, all on addition of all terms, that is 262. Hope you understand. And now let's move to another. You can try these questions. There are few questions right here. Here, right, n runs from -1. We have to first input will be -1, then it will be 0, then n runs from, the value will be -1, 0, 1 and 2. So this is the value. Next, k runs, k and it doesn't matter, it's just a generic name. N runs from, k runs from, now this time k runs from 1, 2, 3 and 4. K takes the value 1, 2, 3 and 4. K runs from 1 to 4. In third, you have to be careful right here because lots of fraction is involved. Now again, k equal to 1, 2, 3, 4, 5 and 6. You have to take the value from 1 to 6. Now you can do easily. Example 6. Now read it using sigma notation and you can see the question. This is a finite series. Take note of it. And first we have to find Tn, and the way of finding Tn is same as before, general term. Like we have to first distinguish it is a linear or a linear or a quadratic. We can easily see it's a linear. The gap is 3. First difference is equal, so it's linear. But let's go by procedure. What to do? Okay, what to do? There is first find, is it a linear or quadratic series. Now this is a series, we can call it a series, quadratic series. And second, find Tn. Then we can easily find Tn in general term because we have practiced a lot of question previously on previous examples expressed in summation sign. So let's see. Our given series is 1, 4, 10 and 16, 13 and 16. It is a finite series. Now the gap is 3. We can easily see the gap is 3. If we subtract the second and first, that is 3. Our first difference is equal. So let's keep in mind, if first difference is equal, you can see if first difference is equal, then it is a linear series and its Tn will be Tn equal to An plus B. Since first difference is equal, it is a linear series. We know that very well. Tn is equal to An plus B. It's equation 1. We need it. And now we have the value of A. The first difference is always A. here a is equal to value of first difference, which is 3. Now after this you can say a plus b is equal to first term of the series. First term of the series is 1. First term of the series is 1, so that will be 1. A plus b is equal to 1. We have the value of a, so we put it. We substitute the value of a as 3. Then on calculation b is equal to 1 minus 3, b is equal to minus 2. Now putting the value of a and b in equation 1, we get, instead of a we put 3, instead of b we put a minus 2. So 3 and minus 2 is our Tn. So we have completed up to this step. Now express as summation. Now taking summation on both sides. Now I will explain this 1 to 6. Tn is equal to summation 1 to 6 Tn minus 2. So always it starts from 1, not because here is 1. Don't get confused. The first term is 1, so it's written 1. It's not like that, okay? It runs from the value of n is taken as 1, and it is taken up to 6 because there are 6 terms, and I have told you in the beginning also it is a finite series. There are finite number of terms, 1 2 3 4 5 6, finite number of terms. So if it was plus dot dot dot, then we have to write infinity. Okay, now so hope you understand. Nothing is different, just we have to put the parameter on it, and start always from 1, and int at, if it is a finite series then count the number of terms, then if it is infinite series just put infinity sign. Okay, now there is exercise for you. Yes, there is exercise, and it's a fraction also. We know how to find the Tn of a fraction. We have already done this type of question, where we have already found the general term of the sequence. We have done on sequence where the terms are given as a fraction. So we have to find the general term of the numerator and general term of the denominator, then we can express it at, here we have expressed as a summation sign. Here only one term is infinite term, so here you have to write infinity while expressing in some sigma notation. So let's move to another example. Okay, next example 7a. We have 7a and 7b, two example from on the same number. Let's see this example. Rewrite the series 8 plus 4 plus it's a decreasing series. You can see 8 4 2 1 half half half. It's a decreasing series. Using sigma notation, we have to rewrite it using sigma notation. Means we have to find Tn, then we can apply a sigma as we have done in previous questions. And let's see the solution. And let me tell you one thing first. This series does not apply linear and quadratic sequence or series style of doing. We won't apply that technique to we find general term in this series. It has its own method. We can identify, we can distinguish this series as a linear or quadratic. We have to do by a different method. Let's see. Given a series, it has its own technique, it has its own way of doing. So we can't apply that concept of linear or a quadratic series or sequence in this question. Here first term, let's see first term. it's 8, which can be written as 2 to the power 3 upon 2 to the power 0. While value of 2 to the power 0, value of 2 to the power 0 is 1. Value of 2 to the power 3 is 8, 2 to the power 3, which is 8, and 2 to the power 0 is 1. So 8 by 1, 8 by 1 is 8 itself. So we can write 8 as 2 to the power 3 and 2 to the power 0. Let's see T2, which is 4. That means 2 to the power 3 upon 2 to the power 1. That is 4, isn't it? You can use your calculator and you can see 2 to the power 3 is 8, and upon 4 upon 2 to the power 1, which is 2. That means it is 4. So 4 can be written as 2 to the power 3 and 2 to the power 1. Similarly, T3 can be written, T3 is 2, and which can be written as 2 to the power 3 upon 2 to the power 4. Now 2 to the power 3 is, we can write here 2 to the power 3 is 8 and it's 4. So 2 divided by 8 divided by 4, which is 2. Next, T4 is equal to 1, which is 2 to the power 3 upon 2 to the power 3. That's 1. 8 upon 8, its value is 8 upon 8. So we are forming a trend, we are making some progression. We're clearing the hurdle, and we're going towards tnth term, isn't it? We are on T5 right now, and now it is, see, 2 to the power 3, which is 8, upon 2 to the power 4, which is 16. That means it is 1 by 2. Now similarly, 2 to the power 6 is 1 by 4, which is 2 to the power 3 and 2 to the power 5. And now 2 to the power 3 is 8 and 2 to the power 5 is 32, which means it is 1 by 4. Now, following the trend, following the pattern how the number are formed, the structure of the number, how they are formed. In this type of question, what we have to see is which are the fixed term. Which are the fixed term? Let's see. 2 to the power 3 is fixed, isn't it? In every term, 2 to the power 3, we can see 2 to the power 3. That's fixed. So in our Tn also, while writing Tn also, we have to fix our 2 to the power 3. Now it will be 2 to the power 3 on Tn also. Another fix is 2. See, in denominator, base is 2, isn't it? 2 is base, and power are changing. Only the movable, only the changeable part is the index part, the power part of a denominator. So the base part of denominator is also fixed. Power part is movable, so it will be represented by n. Now, not simply by n. Now let's see the relation between n and the power. 1, 0. While there is 1, it is 0. While there is 2, it is 1. While there is 3, it is 2. It's decreasing by 1. You can see the pattern. You can see the progression. It is decreasing by 1. So if here we have n, then here we will have n minus 1. Isn't it? Now this is our Tn. This is the way we form our Tn in this type of question. We don't apply the formula or concept of linear or quadratic sequence. We just make by the method, the manual method, we can say. It's like a manual method, we can say, isn't it? Now the structure of Tn, I think it's clear to you. If there is 1, there is 0, 2, 1, 3, 2, 4, 3, 5, 4, 6, 5. Means n is decreasing by 1. In the index of denominator 2, here the value is decreasing by 1. Okay, now this is the Tn. Now rewriting on the summation sigma notation, again applying a summation on both sides. Both sides. Therefore, summation 1 is to 7. Now first n runs from 1 to 7, because there are 7 terms and it is a finite series. So we must write the finite number 1, 2, 3, 4, 5, 6, 7. We have 7 terms. So n runs from 1 to 7. Now this is representation on sigma notation. Now I think it's clear to you. Now you can try other question which will be shown soon, sooner. So we have to, in this type of question, we have to just see the fixed part and movable part. We have to identify, we have to recognize the fixed part, and that fixed part will be same on the Tn term also. You can see 2 to the power 3 is same, and the base part is also fixed part. Only the movable part is the power of the denominator. Power power on the denominator part, index on the denominator part. And we can further simplify this also. We can just write 2 3 minus n plus 1, and which will be, you can leave like this also, or you can, if you like, you can further simplify also, to the power 4 minus n. This also gives the same result. You can get the same result. Just let's check if this is Tn. Let's check the third term T3. Let's check third term randomly. We selected third term 2 4 minus and is 3, so which will be 2. Just 2. Is our third term 2? Yes, our third term is 2 right here, isn't it? So we can use this also, we can use this also, as you wish. Okay, let's move to the exercise part. Try this, and using sigma notation, the question is same as it was given in 2 to the power. It is in 5 to the power, isn't it? 5 to the power 3. Now we have to start with the 5 to the power 3. Now this question is also same. We have to start with 3 to the power 3, and that will be fixed. And another question is there, and this question is a little bit different. Here first term is, now let me give you a little slight hint, 3 to the power 1, and second term is 3 to the power 2. What I told you is we just have to see the fixed part and the 2, it's 2, and t to the power t3 is 3 to the power 3, it's 27, that means 3 to the power 3, isn't it? 3 9 27, and similarly t4 is equal to 3 to the power 4. And what I told you is we just have to see what is fixed and what is moving. Tn, our base 3 is fixed in all terms, so 3, and power is moving 1 2 3, index is moving, but moving in such a way that where value of n here, and 1 is equal, 2 is equal, 3 is equal, 4 is equal, so n will be equal. Now this is our general term, isn't it? Now writing on summation, sigma notation, Tn is equal to Tn, which will be equal to, here also it's Tn 3 to the power n, but it must be from 1 to it's infinite series, see, dot dot dot, so it must be infinity. Here also 1 to infinity. Now, this is the solution, isn't it? This is the solution of this question. Now let's move to another example. Example 7b, I think 7b. We have already done second 7a. Now find nth and 17th term of a given series. Now series, you can see the series 4 16 and 100 and 144. Now let's see how to do it. A solution, a given series, is 4 plus 16 plus 36 plus 64 plus 100 plus 144. It's infinite series. And if you are curious, then you can tell me which will be the next term on this series. Next term 4 16 36 64 then 124, means these all are the square of even numbers. 2, it's the square of 2, 4 6 8 10 12. Now it will be square of 14, that will be 196. Now they all are the square of even numbers, isn't it? 2 start even number, 2, 2 square, 4 square, 6 square. So now let's see, it's 2 square, now it's 4 square, 6 square, 8 square, and 12 square. Now consider those value inside the bracket, not the square. We just leave the square, only 2 will be taken. We consider only 2, 6, 8, and 10, and we find the general term of these numbers, 2, 4, 6, 8, and 10. Now for this we can just see it. Now the difference between 2 and 4, that will be 2, 2, 2, 2, and 2, and first difference is equal. We can see first difference is equal. That means as we have all know, first difference is equal, then it is a linear series. Sequence and series, same thing. uh, Same concept is applied in sequence and series. Sequence and series are not same, but concept to find the general term will be same on sequence and series both. Since first difference is equal, it is a uh, linear series. It's written sequence, it must be. But we cannot sequence because we have created our own sequence here. So it's written sequence because we have created our own sequence. The question is series, no doubt about it, but we have considered a sequence. So Tn equal to, we have Tn equal to an plus b, and that's equation 1. We need that, we need this equation at last. Finally here we know the value of a, isn't it? First difference is always a, first difference is a, so we have a already. And next is a plus b is equal to, here a plus b is equal to first term of the series. Our first term of the series is this series or sequence, our sequence. In fact, first term of our sequence, we have not this one, this one. If we for, we are not considering this, we have made our own sequence, and we are finding the general term of this sequence, not this sequence right now. At a is 2, 2 plus b is equal to 2. That means b is equal to 0 because 2 and 2 got cancelled right here. Then b is equal to 0. Putting the value of a and b, we can see tn is equal to 2n plus 0 is equal to 2n. Now our tn is nth term. Nth term is not 2n. Okay, nth term is not taken. Nth term of given series, the given series which is on question, is the square of this part is 2n square, which is equal to 4n square also. You can write 4n square also, or you can just leave 2n square. Understood? Because see, all the tn term will also be tn square, isn't it? The tn term will be tn square. Our tn is 2n, so it must be 2n square. Now we have to find the 17th term. When n is equal to 17, 2 dot n dot 17, value of n is 17, which means 34. Square 44, you can use your calculator and you can quickly find out. It is 1156. This is our answer. The given series, this is the general term for the given series. This is the general term for this series, which we have considered for our convenience, isn't it? To make our tasks easier, to find the general term of this given series in the easier way, we just considered another sub series sequence from the series, and we found the general term as the term here. You can say first term, second term, third term, fourth term, fifth term, sixth term, and tn term. Then tn term will also be square, isn't it? First term is square, second term is square, but tn term also will be square, so it is 2n square. We can write 4n square also. Now let's move to another question. Try this. Find the nth and 12th term of the given series. We can easily find, also write in sigma notation. You can write sigma notation also. It is dot dot dot, so it will be infinite series. We have to write infinity above and 1 and first. Now you can easily find this, do the answer of this question. This is 1 cube, this is 2 cube, isn't it? This is 3 cube. Now we can see the base is not fixed. It's 2 cube. Base is not fixed, power is fixed. So our general term will be, we can easily tell our general term, which will be n cube, isn't it? It's moving. When there is 1, it's 1, 2, it's 2, 3 is 2, 4 is 5. So next, example 8. Rewrite the series. These using sigma notation. Now this question will be done in exactly in the manual method, you can say, without applying any formula, just using the concept. Here t1 is a equal to r1 minus 1. Now see, r minus 1 minus 1 is 0, so r to the power 0 will be 1, that means it's a. Now another t2 is 2 minus 1. Now what I have told, just keep in mind what is fixed and what is changing, what is constantly changing. A is fixed. Let's see, in both first and second term a is fixed, r is also fixed. Power is changing. Here it's 1, here it's 2, but after minus also it's fixed. 1 is fixed, isn't it? Now it will be easier to find the general term. Now let's see. What we have observed in first two term is same on the third term also. A is fixed, r is fixed, 1 2 3 it's changing, but after minus there is only 1. So from these only these three terms also we can easily find the general term. N is equal to, as I said, a is fixed, r is fixed, the moving part is this one, 1 when the 1 2 it's 2, 3 it's 3, so it's n. Now after n also it's fixed, minus 1 is also fixed. So this is our general term. We can easily find, we easily guess it. So let's see in the fourth term also. See, this is moving. When there is 4, it's 4. There is 4, this is 4. When there will be n, it will be n. Now t5, 5. Now tn is equal to a r n minus 1. This is our general term. To write it in applying sigma on both sides, as it is a finite series, it has 1 2 3 4 5, then it will be 1 2 5. We have to apply 1 2 5 on both sides. 1 2 5 tn an. It's easy. Now let's see. I think it's exercise for you. Try this. Rewrite the series. This you can see in this series also. This series x minus 1 x minus 2, it's moving here, right? X is same, it's moving. 1 2 3 means it will be x minus n, and another thing is also moving. See, the power is 1 2 3 4 5, it's 10, means it will be n, isn't it? And on sigma notation that will be n runs from 1 to 10, because it is a finite series, we have only 10 terms, it will be 1 to 10. Now in this also same, there is a denominator, it's 1 and power is 1. Now a minus b is constant. The moving, you can see clearly, see the moving or changing, you can say the changing values are 1 2 3, and this also, this it is in fraction. You can do in the by the previous method, or you can it's for question number 3, and let me give you a little bit of hint. For t1 you can see t1 is equal to 1 square upon 2 square, isn't it? Now t2 is equal to 2 square upon 3 square. Now we can easily find the trend. What's the trend? 3 square upon 4 square, isn't it? 9 upon 16. Now with the trend we can easily find it's n square in the numerator part upon n plus 1 square in the denominator part. It's always n plus 1, isn't it? While there is 3 it is 4, while there is 2 it is 3, while there is 1 it is 2, so it is increasing by 1. So we can write 1 plus 1 whole square, and in sigma notation you can easily sigma notation we can easily write sigma from, it runs from 1 to 1 2 3 4, only 4, and 10th term t10 is equal to, you can find t10 also. Okay, now we are going to learn about a relation between Sn, a relation between sum Sn and term Tn. What is the relation between sum and term? What is Sn? Actually Sn is the sum of n term. Sn is sum of n term, sum up to n term, you can say sum up to n terms, any given n term. N terms, and Tn is our general term. Now, what is the relation between this? Let us consider a general sequence. General sequence means most common sequence T1 plus T2, so common series, in fact series, general series T1, T2, T3, T5, and dot dot dot. It's a and Tn. It's a finite series because the number of terms is definite. So let Sn be the sum of the series. This Sn be the sum of this entire series, means up to n term, which can be written as, so Sn is equal to T1 plus T2, same thing, T3 plus T4 plus T5, and there are other terms, and Tn. When n is equal to 6, then let's see, when n is equal to 6, S6 is equal to, for S6 we have to take only, here there is another term, 6th term, which is right here, it's 6th term is there, 6th term, S6, isn't it? S6 is sum of 6 term, first 6 term, and again when n is equal to 5, 7, okay, there is another term also, T7, which is needed, so let's write it, T7. Now S7 is equal to T1, T2, then first 7 term, T3, T4, T5, T6, and T7. T7. Now, what is the difference between S7 and S6? Let's see. Subtracting S6 from S7, what we get? S7 minus S6 is equal to, now entire S7 will be written, this entire S7, all 7 terms, minus all 7 term, and minus in bracket T1 plus T2 plus T3 plus T4 plus T5 plus T6. Yes. Now, after opening the bracket, the sign will be changed. This plus sign will be changed to minus sign. These all plus signs will be changed. You can see T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 minus T1, T2 minus T3 minus T4 minus T5 minus T6. Now you can see here T1 positive and negative, they will be cancelled. T1 and another T1 is cancelled. T2 is cancelled. T3 is cancelled. T4 is cancelled. T5 is cancelled. T6 is cancelled. Only the term remaining is T7. So if we have to find a specific term, then we can use this concept. Okay, so that's the relation between a sum and term. Similarly, if we practice, T2 will be S3, S2 minus S1, isn't it? T2 will be S2 minus S1. Likewise, here T7 is S7 minus S6, so T2 will be S2 minus S1. Okay, T3 is equal to S3 minus S2. Similarly, T4 equal to S4 minus S3. On same way, T8 equal to S8 minus S7. If somebody asks you T100, then you can easily say it will be S8 S100 minus sum of 100 terms minus sum up to 99 term. If we subtract this sum up to 100 term and sum up to 99 term, then we will get the 100 term, isn't it? Now this is the formula. We have to remember that actually the formula is Sn minus s n minus 1 equal to Tn. Now this is the relation between sum and term. Sum up to n term and minus sum up to one less term and equal to Tn. Now this is the formula we have to remember always. Now you can see and so on. So in some book Tn is also written as An. If question is asked An, find An, then you should get confused. It's An and Tn are same thing. An example, example 9, ninth example. It is related to the previous theory. Sn is equal to 3n plus 5. Find S4, S5. We can easily find S4 and S5, and we can have to find A5 also. It's given here. Sn equal to 3n plus 5, and when n is equal to 5, because this is the input. It's like a function. Input is 4 when n is equal to 4. S4 equal to, now 4 takes the position of n. It's like function. It's input. That's 17. Now let's see what Tom has to say. Tom, if he knows something, then he will appear and tell you something. N is input value. N is input variable, and 4 is input value. So 4 takes the position of n, or we can say 4 is replaced by 4 replaces n. N is replaced by 4. This concept is similar to what we have studied in function. So I think Tom makes it clear. Now we have to find n S5, that is when n equal to 5. S5 equal to now 20. Now 5 replaces n. N is replaced by 5. So the calculation is 20. S5, S4 we have found. Now A5 is before we can easily say S5 minus S4. Now let's see. That is 20 minus 17, which is 3. Now in this way you can do any sort of question. You can solve any question. Therefore A5 equal to 3. Example 10. You can see the question. Here we have to find T3. Now you can say T3 is S3 minus S2, isn't it? And you also can say S5, T5 is S5 minus S4, and also you can say T7 is S7 minus S6. We are going to do same thing on this example. This is important example. It will be asked in exam also. Solution here. Sn equal to 4n square plus 5n plus 8 when n is equal to, we know T3 is equal to S3 minus S4, S2. Now 4 dot 3. Now here n is replaced by 3 and minus sign, and for this S2 you can separately find S3, S2, S7, S6, S5, S4, and you can subtract, or you can do in a in a shortcut way, like this also. Here this it is for this part is entirely for S3, and this for S2, and this part is entirely for S2. It is S2, isn't it? It is S3. S3 minus S2, T3. On calculation, you have a calculator, you can use it, and that's 25. Now again we have to find T5. It's T5 now. T5 is S5 minus S4. Now first part is for S4, 4 dot 5 to the power 2 plus 5 dot 5. This is n, this is n, this is also n, and here right here it's n, it's n. Now you have calculator, you can use it. 13, 133 minus 92. This entire part is 133. This is entire part is 133, and this is entire part is 92. Now on subtraction we get 41. Now finally we have to find T7. Also T7 is equal to S7 minus S6. Now S7 is 4. Now this is the value of n. 7 is the value of n. And here also this is n. 6 is n. And again this 6 is also n. Now on calculation, the entire value will be 239 minus 18, 182, and the answer is 57. Now we can easily find now T3 plus T5 plus T7 equal to 25 plus 41 plus 57, which is equal to 123. And this is the answer. Therefore, our answer. Okay, this is for you. Do all these questions in the same way. You have learned. Now it's example 11. T6 is equal to 50. Tn is equal to 2. Now it's a general term is given right here. This is the general term. And we have to construct a series of first 5 terms and write the sigma notation. T6 is equal to 50 and Tn is equal to general term is given. Now we have to find construct a series of first 5 terms. Means we have to go in a reverse order. We already have T6, so we have to find T5, T4, T3, T2, and T1. So our input will be first input will be n is equal to 6, because the Tn is defined as single n. Then we have to start with if the Tn is started with only n, then we have to our input will be start from n is equal to the given value 6, isn't it? And if Tn is given in the form like n plus 1, then we have to start with one less value. So we must start with 5, isn't it? For in this case we have to start with 5. If it is Tn is expressed like Tn minus 1, then we have to increase the value. In this case we have to start with 7, n is equal to 7. One more value here, one less value, that will be n equal to 5. In all cases we get n T6. We get T6 here, also we get T6 here, also we get T6 here, also we get T6. So we have to start when n is equal to 6. Here we start with n equal to 6 and move on to 5, 4, 3, 2. So that's confirms. Now T6. Now T6 is equal to 2T 6 minus 1 plus 5, 6 square plus 6, which is equal to 50. We have the value of T6, that's 50. So we apply it. Okay, you can see T6 is given as 50. So we replace T6 with 50 and T
Now t6 minus 1 is t5, and this is the calculation of 5 and 6 square is 180, and 6 is 6. You can see the calculation, or 50 is equal to plus 186. Then we will subtract it. 50 minus 186 is equal to 25, and or 136 is equal to 2t5. Now we finally found the value of t6. Okay, now it's disturbing whatever we have written previously. Now let's remove it. This will also disturb us. When n is equal to 4, we will move in the decreasing order. N equal to 5. After 6 it is 5. Now t5 equal to 2t5 minus 1. The value of n is replaced on the tn. Wherever there is n, where n is replaced by 5, or t5. We have the value of t5, right? It's minus 68, and so it's t4. On subtraction, it's t4 on 25 equal to minus 99. Now another, when n equal to 4, now we can easily do t4 is equal to 2t4 minus 1. Wherever there is n, it is replaced by 4. It's like a function, right? N is like a input value, and n is the input variable, and 4 is like an input value. Therefore t3 is equal to 91.5. On calculation, it's on calculation. You can do your calculation on your own way. Similarly, when n is equal to 3 and t3 is equal to 2, t3 minus 1 plus 5 plus. Similarly, we have to find n is equal to, when n is equal to 2, we will get t1. Or t2, we have the value of t2 as 69.75 equal to 2t1, 2 minus 1 t1 plus 20 plus 2. Now in this way, t1 is equal to, we get the value of t1 as minus 45.875. Now we have to construct the series. The series will be the required series. We have first term, we have second term, we have third term, we have fourth and fifth term. So we can easily construct the series as t1 plus t2 plus t3 plus t4 plus t5. Now the series will be, you can see, minus 45.875 minus 69.75 minus 91.5. Now these are operator. Negative sign is an operator. Now if the terms are connected with the operator, then it is a series. Now we have to write in sigma notation. We already have tn, so we don't have to worry about it. In sigma notation, we have tn is equal to 2. It's given in the question, plus n, and applying sigma on both sides. On both sides. Now it always starts with 1, and ends with the number of terms. We have only 5 terms, so it is 5. It ends always with 1. Okay, don't forget. Just apply this, and it is our sigma notation. You can use bracket right here also, if you like. Now sum of the first 3 terms, now s3 is equal to t1 plus t2 plus t3. If we add all these terms, the value will be, first term is 45.875, and second t2 is minus 69.75, and another value is minus 91.5. Now on addition, or we can question is, try this. If the general term of the sequence is given as in this way, it's given, and the construct an infinite series of construct an infinite series means you have to write dot 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 after 5 terms. Okay, and you just have to write dot dot dot. First you will get 5 terms. You can find 5 terms when n is equal to 1. If you apply n equal to 1, 2, 3, it will be 5 terms. N is equal to 1, you have to apply 2, apply 3, also use a value of n as 4 and 5, and then you have to write dot 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 infinite series. Okay, and now after finding 5 terms and the sigma notation, you can apply also sum of first 5 terms. You can do that. Now we are going to study about patterns. And what is pattern actually? A pattern is a repeated decorative design, and the same thing is repeated again and again, and it gives a nice visual experience, isn't it? You can see in the bathroom, uh, there is a pattern of tiles, isn't it? Bathroom, on the way, on the floor, on your veranda, etc. It's like a model or a design. It's a model or a design or something repeated decorative work. And now, here we are not going to do about that. We are going to form a sequence from the patterns, and we're going to solve the problem right here. And now, yeah, let's move forward. One example, example 12, up to I think up to example 11, it's everything is understood up to 11, and now we are doing example 12. It's about the question is about the pattern. Study the given pattern. You have to study the given pattern, and from there, whatever question is asked, you have to answer. You have to calculate, or you have to answer it, and answer the given questions. Now this is the pattern. Pattern is started. There is a one dot in the first figure and 3 dot in the second figure. You can see, you can clearly see one dot in the first figure, 3 dot in the second figure, and still third figure is not completed. Now it's completed. There are 6 dots. They are dots. It's in bigger size, but they are dots. There is 4, and you can see the pattern, isn't it? Only 1 in the first, 3 in the second, 6 in the third, and similarly I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 on the third. Now what are the questions to be answered? Let's see. These are the question. Add one more figure to the given pattern. We have to create another pattern right here, according to this fixed rule set by the sequence of the dot formed here. Find the general term. We have to find the general term of that sequence represented by the given pattern, and we have to represent in the sigma notation also, and we have to find the number of dots in the 10th figure. Means there are the 6 dots on the third figure, so how many dots will be on 10th figure? We have to find the general term, and if we find the general term, it will be very easy to calculate the number of dots on any figure, any number of figure. Now let's add one more pattern. You can see here, it's one. You just see this side of the figure. There are 1 in the first, 2 in the second, and 3 in the third, 4 in the fourth. Means 5. There will be 5 in this line. 1, 2, 3, 4, 5 in this line, and 1, 2, 3, 4, 5 in this line also. So we can guess the pattern, isn't it? Now let's start.
the first a number, the solution of the a number. That's the next figure is on given pattern is now 1 dot. You can see it. Now there will be 5 in the base. There are 4, means 1 will be added, it will be 5, and we can just put the dot here, right here, right here, right here. Then we can easily complete this next part pattern. One in the middle of these two, and another will be on the middle of these two, another will be in middle of these two, another will be on middle of these two. Now on middle of these two figures, these two dots, we will put another one right here, and on the middle here, right here, on the middle, right here, and again on the middle, and again in the middle, and in the top. Now see, there are 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 5. Everywhere 1 is increased. From this side also you can see one dot is increased. From this side also 1 dot is increased, and this side also 1 dot is increased. Now this is the pattern, and let's quickly move to another general term. We have to find the general term, and for that let's see the number of dots. It's 1, we know that, and it's 3. We have to form the sequence from the dots. This is 6, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have to find out, is it a quadratic sequence or a linear sequence? 1, 3, 6, 10. Now let's see what happened. We have counted the dots on previous slide. We are going to use those dots to construct our sequence. Now see, the first 1 is from the first figure, 3 is from the second figure, 6 is from the third figure, and 10 is from the fourth figure, and 15th is from the that figure which we have drawn as part of our solution. Now the confirmation, that sequence is constructed by the counting the dots of each figure. Now this is just a confirmation. We know that. And now let's see the difference between these two conjugative numbers. Difference between the conjugative numbers. If they are equal on, then it will be the first difference. On equal on the first difference, then it will be the linear sequence. So let's see, is it a linear sequence or not? 2, 3, it's not equal, isn't it? Our first difference is not equal. Our first difference is not equal. That means it is not a linear. So definitely it is a quadratic sequence. Now 1, you can see 1. You can see again 1. Difference between 3 and 4 is 1, and 4 and 5 is also 1. Our second difference is equal. So it is a second difference. It's equal. So if second difference is equal, you can see this part we have seen lots of time as we are nearing the conclusion of this topic. So you have seen this keep in mind box many times, and I think everything is now very much familiar, habitual to you. All these processes are clear to you, and you can apply it without seeing also. Now this process, we will exactly follow this process. So we are in the first step right now. If the difference is equal, the second difference is equal, so then it is a quadratic sequence. So we are going to write that thing. Since second difference is equal, it is quadratic sequence. Now for quadratic sequence, what happened? Tn is equal to an square plus bn plus c. So we are going to write that. Therefore Tn equal to an square plus bn plus c, and it is equation 1. We need this. Now we have 2a is equal to 1, therefore a is equal to 1 by 2. Isn't it? 2a is the value of second difference. What is our second difference? You can see our second difference. Our second difference is 1, which is equal to 2 and a. Our second difference is 2a, and value of a will be 1 by 2. So we found the value of a. Still we have to find b and c. Now we are going to use, we have up to now we have used this and this. Now we are going to use 3a plus b is equal to first term of first difference. Now this entire row is the first difference row, and its first term is 2. So this 2 is equal to 3a plus b. 3a plus b. 3a plus b. Now 3a plus b is equal to 2, isn't it? 3a plus b. Now we have the value of a. We are going to substitute it. The value of a. This is the value of a. We have substituted it.
again 3 by 2, 3 ones are 3 and 2, and now we can easily get the value of b is equal to 2 minus 3 by 2. Now we take the LCM 2, or you can use your calculator. Therefore b is equal to 1 by 2. You can use your calculator. B is equal to 1 by 2. Now we found a also, we found b also. Now c, now up to we have done, if you see on this step, then we have done up to here. Now we have this a plus b plus c is equal to first term of given sequence. Now this is the first term of given sequence. That means it is equal to a plus b plus and c. A plus b plus c is equal to 1. That is the first term of given sequence. Exactly same we are going to apply. You can see also a plus b plus c is equal to 1, and we have the value of a, it's tick. We have the value of b, it's tick. So value of a is 1 by 2, value of b is 1 by 2, plus c is equal to 1. This half and half will equal 1, or half and half equal to 1, and this 1 and 1 will get cancelled, then value of c is equal to 0. Now we found the value of a, b and c. Finally, on putting the value of a, b and c on Tn, our Tn is right here in on equation 1, then we find the general term of quadratic sequence. Now putting the value of a, b, c in equation 1, we get Tn is equal to 1 by 2. Now it is like this, n square by 2, isn't it, plus n by 2, n by 2. Then as the denominator is 2, our LCM will be 2, and if the denominator are same, the numerator are just added, n square plus n, and n is common, and so we took the common n plus 1, n plus 1. So this is our general term. Tn is equal to n plus 1 by 2. We have concluded up to second part of our equation. We added one more pattern on one more figure on the pattern, and we just found the Tn, and now I think it's time to apply summation sign. Let's see what's on this next slide. Now recap, it's a recap because we have just moved to another slide. So it's a recap. We have up to now we have found only Tn. We have drawn one figure. Now see, in sigma notation or summation sign, in this notation we are going to apply this notation. Our Tn is, now we have our Tn is, you can see Tn is equal to n plus 1, which we found on previous slide, which we calculated on previous slide. Now applying summation on both sides. On both sides we are going to apply summation 1 to infinity. I will explain this infinity part and this one part. It's simple because it's always 1 at the starting. It means n runs from 1 to infinity. As it is an infinite sequence, our sequence was infinite sequence 1, 3. It was not closed. 1, 3, 6, and 10, 15, and so on. It was not closed sequence. The number of terms was not finite terms. There were infinite terms. Many terms we can find. So it is infinite sequence. So infinity is its destination. Parameter is 1 to infinity. Our parameter is 1 to infinity. 1. It's not because the first term is 1. We haven't written this 1 because the first term is 1, because n starts from 1. Always starts from 1. Now, so we completed this third part also. Let's move forward. D, a number of dots in 10th figure. Now 10th means our value of n is 10. N is equal to 10. We have to replace n with 10 like in function. Now we have Tn is equal to, now n will be replaced by 10. When n is equal to 10, all the n will be replaced by 10. T10 equal to 10 plus 10 plus 1 by 2. So 2 1 is 2, 2 5 is 10. So 11 into 5, that must be 55. Now this is our answer. We completed the entire question. Everything is done neatly, and it will be very easy to understand. Also, it's done in the easiest way to understand. Now
Similar type of question will be given for you as an exercise. Let's move forward. Now try this. You will see the figure. Now study the given pattern. Now see the pattern here. Now the construction of the pattern. See, it's the pattern. Now a question, add one more figure to the given pattern. We can add one more figure. Just see, then it at the base 1 2 3 1 2 3 4 5. It's 1 on the base right here, and 5 on the second base. I think 7 on the third base. So 9 will be on next base. 9 will be on next base. Then you can just leave 1 and 1 from both sides. Then you can make a structure. And now find the general term of the sequence of square on the base. We don't count every square on the figure, only on the base, just 1 5 7 9. It will be our sequence. And sigma notation, and find the number of squares on the base in 10th figure. What will be how many square will be on the base of 10th figure. We have to find that one. And let's move to another question. Similar type of question you will see. Try this. Study the given pattern. The questions are fairly same to everyone. Now here we have to count all the dots. It's 1 and it's 4 and it's 1 2 3 4 5 6 7 8. I think 1 2 3 4 5 6 7. It's 7, not 8. It's 7. It's 7, not 8. It's 7 1 4 7 1 2 3 4 5 6 7 8 9 10. So we can easily see it's a linear sequence, and we can do quite easily. Sequence on the given pattern. We don't have to consider base. In previous question we have to consider base, but in this question we don't have to consider. We have to consider on the entire figure. We have to count the boxes, the squares on entire figure. Another another question. Try this also. Study the pattern. Now see the pattern here. A number of dot is 1 1 2 3 4. It's 4 1 2 3 4 5 6 7 8 9. It's 9. You can join. You have to join this part. You can see this the join. About the join, I think it's 16 right here. Now you have to find the general term of this sequence of dots. Now the questions on copy, you have to copy this time. Now question has asked to copy this figure and add one more and find the general term. Only you have to find on general term Tn and calculate the number of dots on 17th figure. So it's, you can do it this also. Now another question, try this. Study the above pattern. Now this is the different pattern. You have 1 here, right here, and 1 2 3 4 5 1 2 3 4 5 6. It's 6 hexagon. I think 1 2 3
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is it 16? You can count yourself also. Uh, one. I think I started from here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now 13, 14, 15. It's 15, not 16. It's 15. It's 15. You can see it's 5 is added right here, and 9 is added. Means in another 13 will be added. In another 13 will be added. The gap is 4. Gap is 4. It's a quadratic sequence. You have to be careful. Now copy and find thumb and can number of dots on the 7th figure also. Next, let's move. Try this. State the given pattern and answer the following questions. Now pattern you can see right here. It's 1. It's 3. It's a different pattern, but I think we have done this question 1, 2, 3, 4, 5, 6. We have done in starting 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have done this question previously, but the design is different. You have to go by the design. So it's a different question because of the design. And now general term and calculate the number of dots on the 10th figure. So answer will be 55. We know that. You can do this question. Let's move to next question. Our next question is, I think this is the last question. We have to state the pattern as same. The style of the question is same as previous. Now here we have only one dot. We have one dot right here. And let's see. This is the way of construction of the pattern, isn't it? Now dots are filled on the corner of on this corner of. Let me show you the corner. On this corner of pentagon. See, you can see clearly. Now there are a total of uh, 5 dots. 5 dots. In next pattern, let's see. Again pentagon. Each corner will be filled with dots. Just see the top part. See the top part. This right top part. This top part. This slanted part on the top. Now see, only these two parts. The dot will be added on these two parts, and plus on the middle of these two lines. Middle of these two lines, and we will join it. Now, this is the way the pattern is created. And let's see the next one. Number of dots on this is, how many are there? 5 on each corner. 6, 7, 8, 9. So 9. Next is 9. Clearly the difference is 4. That means there will be 13 dots on the next figure. The 5, all the 5 will be on the vertex of the pentagon. On each vertex of pentagon. Here in the middle there is 1, but in this you get 2. See, you can see in that slope part there will be 2 dots. You can see the 2 dots. Here it's 1, 2 dots, and the figure you are going to draw, there will be 3 dots, which you have to draw. There must be 3 dots. Now, first you can draw the line and dot. You can just draw the line and put the dot, 2 dots here, right here and here. Another dot, line, 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 and dot. You can see the dot. Still we have to fill right here and right here. It's a tentative figure. You can see it's exact. Now it's a pattern, isn't it? I think it's a pattern like a construction of chimney type of pattern. You can see this type of chimney on your kitchen. Now this is our fourth figure, and the number of dots here is 13. Uh, 5 on the each corner, 6, 7, 8, 9, 10, 11, 12, 13. So 13 dots. So it's a linear, and the question is same. Thank you for being with me, and see you on next video. Till then, take care and bye.